Yeah, number one is one of the harder ones. So we're going to start with number two. We got oil spill. There's no way I can draw this, but you got an oil spill. Thanks for the compliment. And that's getting bigger. So as it gets bigger, as this spreads out more and more, it's not just one variable that's changing. Your radius is changing, your diameter is changing, your circumference is changing, your area is changing. Those are all rates that are related to each other. The section's called related rates. And they're going to give us enough information to set it up so that we have like one thing missing, and then we'll do some algebra. So let me do one, and then use that to kind of explain. So the first thing I see is area, and we've got a circle. So I need to find a formula that relates the area of the circle to radius. So that's pi r squared. Let's just read through and like talking about square, rectangle, ladder on a wall. There's some pretty interesting problems you get. And then, so there's four things in this scenario that I may or may not need to know, but let me just start talking about it. So A is area. dA dt. That's the derivative of area. Well, derivative is velocity, or how much it changes. So dA dt is the change in the area. And then pi is not a variable, it's just a number. And then r, same idea. R is radius. And dr dt is the velocity of the radius, or the change in the radius. So I could find A. I'm not going to really need it. It'd be 64 pi if I want to do it. With pi r squared, you do pi times 8 squared. The change in the area is what I'm looking for. How fast is the area increasing? So this is what I want. The radius is 8. And the change in the radius is positive 6. Why is it positive? Because it's increasing. Sometimes it's decreasing and you would put it. So what we're going to do is, because we've got velocities to work with, right? Changes, velocities. We got to get to the derivative level because that's where like, the velocities come from. So if you remember in implicit differentiation, we had there was a y. You could theoretically solve for y. And so to represent the chain rule for that, we multiply by dy dx. This is the same thing. These are all related to time. So whenever I take the derivative of any variable, multiply by d whatever that was, divided by dt, because that variable is changing with time. So the derivative of a is 1, right? But you took the derivative of a variable, so you multiply by dA dt. So this is basically just saying the derivative of a is the velocity of a, which we kind of already know. But just talking through how to get there from here. Then take the derivative of the right-hand side, so bring down the 2, times pi r, the pi just stays, r squared reduced the power by 1. And I took the derivative of an r, so there's like this chain rule piece. I don't know what the r equation is, but it's like got a little guy kind of like in there, and this is the derivative of that little guy. And then they're usually going to give you everything except for 1, or enough to like work your way to everything except for 1, and then you can just solve. So dA dt is what I'm looking for, so that just stays there. 2 pi r is 8, dr dt is 6, so that'd be 96 pi. That is the change in area. So what's the units of that? It's not per minute squared, because now we're getting into acceleration. There is a square, but it's not the minutes that are squared. Area is 2 dimensions, right? Like length and width. So the area changes at the meters squared per minute. this was changing, what would the label be? It would just be meters per minute, because the label line radius is meters. Yeah, what's that? Question on this. You say you hate word problems? What I'm trying to do is get auto word problems as fast as I can. I get it. Question on this one. I can answer, go through. I mean, that's the first one you saw. I don't know if you know what to ask yet. I think I can do before I do another one. Okay. Let's look at. Come back to that one. The cold ones are the tougher ones. Let's try this one. Is that number 4? Why does it show me numbers? So first of all, read through it and see if you can identify the formula we're going to start with. The circumference of a circle, area of a rectangle, volume of a cube. What do we got? So I've got area. I see it's a circle, so it's the same setup as the last one. They're not all this, and we will definitely do several that are not. This just happened to be another circle. So if you want to make this stuff on the side, I think that's really helpful, but I'm not going to make you, like in physics, doesn't Rod have like a process where it's like write down everything you know and then draw, like that kind of idea? So that's not a bad process to do. Again, I'm not going to make you, but if you want to like write down and label what all those are, kind of help yourself organize it, that's definitely not bad. I'm just going to start taking the derivative, and then the reason I don't write all those, the reason I don't just automatically say write all those is because like now I find out that I didn't even actually need A. So if I had gone through and found out what A is, it's just kind of a waste. It's not a huge waste of time, but when I get to here, I know these are the things I need, and then I can look back and see. So I'm looking for the area changing. So that's E dt. That's what I want. And then 2 times pi. So the radius is 8. What's dr dt? So if I combine some of the things I heard, it's negative 1/2 or negative 4 over r. Because r is 8, right? So that goes there, so that's where the 4 over 8 or 1/2 is coming, but it's decreasing. So I'm going to do negative 1/2 or negative 4 over 8, like it's the same thing. But I think it makes sense that if the radius is getting smaller, the area of the circle is getting smaller too, right? So it should be decreasing. But if I multiply these, I get negative 8 pi. Again, area is 2-dimensional, so it's centimeters squared per hour. Question on that one? Alright, let's try one of the colors. That's area circle again. What number is this? You said let's do 7? 7 a cone one? Oh, okay. That's fine. Alright. You will not have to memorize the formulas for these, because the AP test gives them to you. So I've got a sphere, and it tells me volume. So I need the formula for the volume of a sphere, and that's it. Are you, like, is it okay if I say try it, or should I just keep going? Try it, okay. Try it. Take the derivative, and whenever you take the derivative of anything, multiply by t that thing over dt. And I want to do a cone one, and I want to tell you the formula for something. I'll let you do. So if I take the derivative here, the derivative of v is 1, because I took the derivative of v and multiplied by dv dt. And this is the same as saying like position acceleration. This is an amount, and this is how fast that amount is changing. If I take the derivative here, bring down the 3, it'll be 4. 4 times 4/3 is 4 pi r squared times dr dt. We're looking for this, and it's by itself, so I'm good. My radius is 6. And dr dt, put that 6 there, so it's 3 over 6 or 1/2, whichever you prefer. Yes, is that why you're getting calculated? So yeah, first of all, you can leave it. So there's no reason you have to get involved in that if you don't want to. But I don't know. 6 squared is 36. Half of 4 is 2. So 2 times 36 is 72 pi. What label here? 3-dimensional, right? We have value. So it's inches cubed per second. Per second, because we're looking at a rate of change of velocity. And the cube is because it's 3-dimensional. How many had that before I got to it? Did I go too fast? Okay. Question on that one? Alright, go to number, I don't know what number it is. There's one that's like a square, this one, whatever number that is. Tad, that sounds familiar. I think this is Tad. So, I don't know if you guys know the formula for this. Area of a square, if you have the diagonals, I could like go through and make you figure it out. Does everybody know it? If I tell you the diagonal of a square is 6, can you tell me the area? So it comes out, it's not that big. The area is 1/2 times the diagonal squared. So I'm not going to do this problem. I'm not going to wait for you to do it right now. I'm just giving you the formula so you can do it on your own. I want to go back to number 1. Because that is probably the trickiest guy. Let's see why. No, it's like the diagonal squared over 2, if you want to write it that way. If I wanted what you said, I'd have to put parentheses. Alright, so I've got a cone. So I'm at number 1. That's number 1, right? Okay. So I've got a cone. I'm pouring water into the cone. So as I do that, the height of that water is changing, the radius of the water coming up is changing, the volume is changing. They're looking for the rate the water is being poured in. That's the change in volume. So I need a formula that tells me the volume of a cone. Again, I will give it to you. I'm just curious about my notes. One-third base. Oh, like the base. I'm just going to say false. Yeah. No, it's 1/3. It's 1/3. I'm trying to think if you meant this somehow. It's 1/3 pi r squared h. So is that like what you meant for the I don't know. You're taking the area of the base and multiplying by height. Got it. Okay. So that's just a different way to write it. Okay, so let's go through and like figure out what we're going to need to know and start looking at. Because there's a little problem if we just start going right now. Well, maybe you can see the problem right now. Probably can. It's not even necessarily that it's difficult, it actually just results in a problem we can't solve. But why is that difficult to take the derivative? Because there's two variables, so what am I going to have to use? I'm going to have to use product rule. So this is really, I'm not going to have to do it. I'm showing you how to avoid it. I want to show you like why it would be there and then how to avoid it. But really, like I could factor out the 1/3 pi, and then that's product rule because that's two variables being multiplied together. But I'm not going to do it that way. I am going to say I'm going to do that. Take a second, see if you can figure out what I did. And the point of me doing it is to try to get it into one variable. Now I've got only agents, so it becomes that. Can we see what I did? Comes from there. So, I've got a cone. Ooh, that's good. And as it goes down, so the height is 30 and the radius is 10. Well, as the water fills up, you'll just get similar triangles. So the point is that the ratio between the height and the radius will stay the same. So isn't it true, just given this, that the radius is the height divided by 3? Or 1/3 times the height, so the radius is 1/3 of 30. So that ratio will stay the same, as we're filling up the cone, and they'll usually give you a pretty friendly ratio, it'll be 20 and 10, or 30 and 10, or 40 and 10, they don't go crazy with that. And again, I'm doing that, because this sucks, I've got to use product rule, and I don't want to. So I'm going to just plug that in. The 1/3 each in place of the other. With that. So then what this really is, it would be, so 1/3 squared is 1/9, yes? Times 1/3 in front. So that's 1/27. Pi. H to the what? This is the part where you tell me the what. Cubed, right? Because H squared times H. And volume has to be cubed. So volume has to have 3 dimensions. So it should be, whether it's 1, 2, 3, or 1, 2, 3, you gotta have 3 variables. 3.
For that, would it always be the ratio is you take the top base
So I think what you're saying, if this was 20 and 10, that would change it. Then this would be 1/2 each. So it'd be 1/4 times 1/3, so 1/12. Is that what you're saying? Okay. Did I answer your question? Okay. Alright, let's take the derivative here. So the derivative of b is dv dt. Bring down the 3, multiply by the 1/27. That is 1/9. Pi h squared now, because I reduced the power by 1, and I multiply by dh dt. And then I think we know everything else. So 1/9 pi h is, well, the water level is 7 inches, so that's 7 squared, and then dh dt. So the water level rises at a height of 3. So rises makes it positive. It's going to be positive 3. And then, you could leave it there if you wanted to keep going. 3 times 1/9 is 1/3. So it would be 49 pi over 3. 7 squared. But I would just stop here. Yeah, wait, no, sorry. You would have to square the 7. Because that's not one of the 4 basic. So you'd have to go 1/9 pi times 49 times 3. Questions on that? Oh yeah, I forgot the units. Yeah, what are the units? Inches cubed per whatever. And I know it's cubed because it's volume. Volume has 3 dimensions in it. Like it's got a third power up here. Thank you for reminding me. So that worksheet I think should be reasonable after me going through these. And then tomorrow we get into like some more difficult versions of these. Of course, questions for me? So if you want to go to the plate now, you're welcome to. I'm gonna stay here.